Alrighty, hello Russ and TAs and class. In this video I'm going to go over my MIPS implementation of the Enigma machine that I did for my project. I guess before actually going in and diving into the code, first of all we should explain how the Enigma machine actually works. So I pulled this off of a video off the internet, but we can see that there's some main components. There's going to be a keyboard in which you type, and then a plug board, and then there's going to be 3 rotators and a reflector. So how the machine works is we're going to type a key in the keyboard, it is going to go into the plug board, and it's going to find its equivalent, and then it's going to send that signal into the first rotator or the rightmost rotator. Again, shift that, send it to the other rotator, shift it again, and then send it to the next one. It goes to the reflector, and then it travels all the way back. So basically it's just looking stuff up in these two sides of each rotator and reflector, and in the end it's going to return a key to you. So we can kind of see the path here with the green line, how it's sent, and then it's reflected, and then with the red line we can see where it is reflected to. I guess that's the best that I can do as far as explaining it. Let's actually jump into the code. I do have Mars running on here to actually run the code with the same file on there, but I'm just gonna walk through it on VS Code just because it looks better. Alrighty, so first of all, we have to define the plug board. This is gonna have to be a one-to-one swap between the alphabet. So if we see here, the Z is in the position where the A would be, and then the A is going to be in the position where the Z would be, P is where the B is at, and then B is going to be where the P is at, so on and so forth. So it has to be all pairs. And then we can define a key, which basically describes where the 3 rotators on what position they're going to start. I just provided the key Russ, and the first one is going to start at the R, the second one at the U, and the third one at the S. Then I provided the actual alphabet as a string, the actual encryptions or ciphers for each of the rotators as were in the original machine, the actual cipher for the reflector as was in the original machine too. These are the actual notches that were used in the machine too. Those are going to come into play later when we are actually rotating those rotators, and the key currently is just the alphabet. There is supposed to be a capability for changing these notches in the actual physical machine. They had to implement a certain ring that would actually decide would kind of change the behavior of this notch, but I decided to do without that for this project because it was pretty heavy already. Alrighty, so let's look at the main code. This is basically all that it's doing is reading a character from the keyboard, and then before we do anything else, we're gonna set the rotors based on that key that we have over there. Let me see if I can just jump to this. I don't think that would work. Alrighty, let's see where that actual function set rotors is. It should be right over here. Yep. Yeah, it's just gonna rotate them to the position that we specified with the key basically, and it uses this rotate once subroutines as well, which all that subroutine does for each of the rotators is basically make one full rotation of the entire key. Alrighty, let's get back to the code. Yeah, basically what we're doing on here is gonna be we're gonna load the actual character that we have once we're ready, and this is, I basically just ripped this off of the example that Russ provided in the spec for the keyboard input. Yeah, once we have that actual typed character, we're gonna go through some formatting. If it's lowercase, we're gonna switch it to uppercase, and if it's already uppercase, then we're not gonna touch it. Another thing that we are doing is we're checking to see if it is a letter or not, because if we don't have a letter but we have a number or symbol, we don't want to do any encryption in it. And then we actually do the encryption on here. We do the forward pass for the alphabet, and then for the plug board, and then for each of the rotators 3, 2, 1, we reflect it, and then we do the backward pass for each of the rotators 1, 2, 3, backward pace for the plug board, and then the backward pass for the alphabet. Once all of that is done, we're going to perform one more rotation. We'll get into all of that on the actual Enigma machine, and then we're just going to print the character. This is all just part of how the keyboard input, and this is where the actual functions or subroutines start. For format character, it's basically just a simple loop. It's checking whether the character that we have matches lowercase a to z yet or not, and then just subtracting 32 of it to actually send it to the ASCII value of the uppercase character. The alphabet forwarding is basically just getting an integer instead of the actual ASCII code, so that it's easier to run through the rotators and the reflector, and we can use it for indexing and everything. And yeah, the backwards run is also doing pretty much the opposite of that. Is just adding 65 to the signal that we have so that we can get the actual ASCII code for it. For the plug board, and pretty much the same thing goes for all the rotators and everything else. Basically, what we're doing is we're loading up the alphabet and the plug board, and then we are checking to find the letter at the index that was passed from the alphabet forward signal. And then so once we find that signal, we're gonna go ahead and load it up. For the backwards run, basically the same thing, but it does it backwards. So if on the forward run we are trying to find the signal that the U has, or let's say, let's find one that's different on here. Okay, yeah, I mean, that doesn't really matter. If we're gonna find the signal that the U has from the forward pass, we find the letter on over here, and then we index it on this side, while on the backwards pass, we find the letter on here, and then we index it on this side. So yeah, that's all that the forward and backward passes subroutines do. The reflect subroutine does pretty much the same thing, but there's only one because as we can see, there's only one process that happens in the reflector. It just kind of bounces the signal back. And yeah, that's pretty much it. As far as the perform rotation goes, in the original Enigma machine, this third or right rotator rotates with every iteration, with every letter that we type, and then if the letter on top of the key here matches the notch that we have provided, the second one will rotate, and then if the letter on here matches the notch that we provided, this one will rotate. There is also a certain wheeze scenario that for some reason happened in the original Enigma machines, where if only the second notch on here matched, but even if this one did not match, then all three of the rotators would still go through one full rotation, so I decided to implement that as well. And yeah, that's pretty much all of the code. So now let's go ahead and take a look at the actual machine and how it works. We're just gonna go ahead and assemble it and run it, and then pull up our MIPS keyboard, connect it to MIPS. I'm just gonna go ahead and clear this, and then we can see on here that if we start typing, we are gonna get the encrypted message over on the output over here. So yeah, that's pretty much my ASM6 project, and yeah, I hope you guys liked it.